you substitute that approximation, finally you get Z equal to RT by 1 plus J2 QE into delta. This is the impedance of your load for any frequency. At resonance, when omega equal to omega naught, delta will be equal to 0. See the formula for delta, omega minus omega naught. When you put omega equal to omega naught, delta will be 0. So when delta is 0, your Z will become Z equal to RT. See, I told you in the offline class, at resonance, your circuit will act like a pure resistor. See here, that is verified here. When you put omega equal to omega naught, the impedance is just equal to RT. You don't have any reactance term here, which clearly indicates that at resonant frequency, the circuit is resistive. That is, the voltage and currents are going to be in phase. Okay, so Z equal to RT, and RT is, it is a parallel combination of R naught, RP, and R. And RP, it is omega naught square L square by R square. So if you multiply and divide by, if you write omega naught L equal to 1 by omega naught C, I can write RP in terms of L, C, and R. RP equal to L by CR. You will get the value of RP in terms of L by CR. Okay, so these things are other notations. This is other ways of writing RP, so which is actually not required. Just we need to know what is RP is L by CR, and we are going to work with Z because the output voltage depends on Z. So see, V naught equal to minus GM VB dash. See the expression for V naught, we have written V naught equal to minus GM VB dash E into Z. So if you now find V in. For V in, we are going to go to the input side. See here, the total voltage is, the source voltage is Vs, the voltage entering your amplifier is Vi, the voltage which is actually entering your base is Vb dash E. So I'm going to measure what is Vb dash E in terms of Vi. So I'm going to use voltage division. So Vb dash E is equal to total voltage into that resistance Rb dash E divided by Rb dash E plus Rb B dash. I'm applying voltage division rule because I need to bring V in somehow in. The V in by V out by V in will be the gain, right? So I need to bring V in inside my expression. So I am going to apply voltage division rule in the input side of my transistor equivalent circuit. So see here, Vb dash E is equal to total voltage into that resistance divided by that resistance plus opposite resistance. So Vb dash it is minus GM Vb dash E into Z, and I'm substituting the value of Vb dash E here. So Vb dash E is this expression. So I'm substituting this expression in terms of Vb dash E here. So I in the beginning we have assumed the gain of the amplifier is capital A, right? So capital A is equal to V naught by Vi minus GM into RB dash E divided by RB B dash plus RB dash E into Z, and substitute the value of Z equal to RT by 1 plus J 2 QE into delta. So once we know the expression for gain, we can find all the other parameters like bandwidth, what is the maximum resonating frequency, what is the maximum gain at not everything we can find easily once we know the expression for capital A. See, whatever you've done in lab is practically finding out F naught and the gain. You have done class C tuned amplifier, right? That is what we are doing theoretically now. What you have done is class C, but what we are seeing here is class A. Class A single tune amplifier. So we are doing mathematically everything. What you have done in lab is the complete practical implementation of single tune amplifier. And this minus sign is coming because it is a common emitter amplifier, and in common emitter amplifier, the input and output are out of phase by 180 degree to indicate that you get this minus sign everywhere. So this is the final expression for gain.